Okay, so this one is moles to volume conversion, and this works only for gases when they're at standard temperature and pressure. So some of the problems that you'll see in worksheets will say, like, determine the volume in liters occupied by 0.03 moles of gas at STP. Now, essentially, it always has to be STP, standard temperature and pressure, because if the temperature pressure is not the standard temperature pressure, then these values would not work, because the warmer it is, the more space the molecules would take up. The colder it is, the less space, because of the being able to expand or shrink. Pressure, same thing. If there's more pressure on the gas, then it's going to be in a smaller amount of space. If there is less pressure, then it's going to spread out more. So standard temperature and pressure is required for this to work. Okay, so 1 mole is going to be 22.4 liters of volume. So think balloon takes up how much space, that's how big your balloon would be. Okay. Now, most of your balloons aren't going to get that big. Okay, so we're going to use this equation in order to make a fraction to cancel what you start with. So if we start with moles, we need to have moles on the bottom so it cancels out, and then we would have our liters on top, and our answer is going to be in liters. If we have liters to start with, we're going to cancel our liters, and then we'd have our moles on the top so that we get our moles for our answer. So let's go ahead and do a couple problems. Okay, so if I start with 47 liters of O2 and I want to know how many moles that is, I'm going to take, I want my liters of O2 in the bottom, so I'm going to put the 22.4 on the bottom, and then I'm going to have 1 mole on top, and then if I take, and remember, multiplying by the top, dividing by the bottom. So 47, I don't need to multiply by 1, I do need to divide by 22.4, and I end up with it's 2.09, so I'm just going to round that to 2.1 because the 9 would round up if I went 2 decimal points. Ideally, if you can do 2 decimal points, that'd be great. And then we have, if we would do 5 moles, 5 moles of O2, we'd have 1 mole of O2 on the bottom and 22.4 liters of O2 on the top. Oh yeah, I meant to show that this cancels with this. This is going to cancel with this. So if I take my 5, dividing by the 1 isn't going to matter, so all I have to do is the 5 times the 22.4, and I end up with 112 liters of O2. Okay, if you have questions on this, let me know.